Welcome to Lab 2 of our Advanced Electrical course. Today we'll be working with a dual color LED and the Raspberry Pi. We'll use the GPIO Zero library to control the two colors of the LED, red and green. In this lab, we'll explore the electrical schematic and wiring of the LED board. We'll learn how to control the LED using Python. Let's get started by first taking a closer look at the dual color LED board and its components. This schematic shows us the components and wiring of the dual color LED board. The board integrates two LEDs, one red and one green, under the same cover, along with 220 ohm current limiting resistors to protect the LEDs from excessive current. Additionally, a 3-pin JST connector simplifies the process of connecting the board to other components. The board has three main pins. Pin R connects to the anode of the red LED. Pin G connects to the anode of the green LED. And the GND pin is the common cathode for both LEDs. Now let's move from the schematic to the actual components on the PCB. Here you can see the 3-pin JST connector, which provides easy access to the R, G, and GND connections. The 220 ohm resistors are clearly visible on the board and are responsible for protecting the LEDs by controlling the current flow. The traces on the PCB connect the JST connector to the resistors and LEDs, replacing the wires shown in the schematic. These traces ensure that power flows from the GPIO pin through the resistors and into the LEDs under the cap, illuminating either the red or green LED depending on which pin is activated. The dual color LED board uses a 3-pin JST connector to connect the anodes of the red and green LEDs as well as the common ground. Let's make sure we connect the wiring correctly. First, connect the JST connector to the dual color LED board. Make sure to use the correct orientation. The yellow wire on the JST pigtail is connected to the R pin of the LED board. The red wire is connected to the G pin, and the black wire connects to the GND pin. Now connect the yellow wire to GPIO 17 on the breadboard for the red LED. Next, connect the red wire to GPIO 18 for the green LED. Finally, connect the black ground wire to any ground pin on the GPIO extension board. I'll be connecting mine to the ground pin located on the bottom left of the extension board. With these connections in place, the wiring is complete and the dual color LED is ready to be controlled through the GPIO pins. Now that we have the dual color LED connected to the Raspberry Pi, we're going to write some Python code to control it. Let's go through the script step by step. From GPIO Zero, import LED. We start by importing the LED class from the GPIO Zero library. This library makes it easy to control GPIO pins that are connected to LEDs or other similar components. While there are other libraries we could use for controlling GPIO pins, GPIO Zero simplifies the process and is particularly useful for beginners. From time, import sleep. Next, we import the sleep function from the time module. This function allows us to pause the execution of our script for a certain number of seconds, which will help us control how long each LED stays lit. Here we define two variables, red and green, which represent the two LED objects. We assign GPIO 17 to the red LED and GPIO 18 to the green LED. Notice that we've named the variables according to the colors of the LED they control. It's important to use meaningful variable names as it makes the code easier to read and troubleshoot. While true. We use a while true loop to create an infinite loop that will continuously alternate between the red and green LEDs. The loop will run indefinitely until we stop the program manually. Print red is on. This print statement will display the message red is on in the terminal. It's a simple way to keep track of when each LED is lit. Red.on, green.off. Here we call red.on to turn on the red LED, and we call green.off to make sure the green LED is turned off. This way, only one LED is lit at a time. Sleep 1. The sleep 1 function pauses the execution of the script for 1 second, keeping the red LED lit for that duration before moving on. Print green is on. Now we print green is on to the terminal, signaling that the green LED is about to turn on. Red.off, green.on. At this point, we turn the red LED off using red.off and turn on the green LED with green.on. Sleep 1. Once again, we pause the script for 1 second using sleep 1, allowing the green LED to stay lit for 1 second before the loop starts over. Since this is an infinite loop, the program will continue to run until we stop it manually. To end the program and exit the loop, press Ctrl+C in the terminal. This will stop the script and turn off both LEDs. Now that our code is complete, let's run it in VS Code. Click the Run button at the top of the screen or press Ctrl F5 to run the script. As you can see, the red LED and green LED alternate every second, just as we programmed them to do. The program continuously loops between turning the red LED on and the green LED off, then switches to turning the green LED on and the red LED off. Since we've created an infinite loop, the program will keep running until we stop it. To end the program and exit the loop, simply press Ctrl+C in the terminal or click the Stop button. This will immediately stop the script, turning off both LEDs and returning you to the editor. After stopping the script, the LED will turn off and the program will no longer run. You can always rerun the script by pressing the Run button again. Now that we've completed the lab, let's quickly review what we've accomplished. We successfully connected a dual color LED to the Raspberry Pi using a 3-pin JST connector and controlled the LEDs through GPIO pins. We wrote a simple Python script using the GPIO Zero library to alternate between red and green LEDs with a 1-second delay between each. For your next task, you'll create a Python script that asks the user which LED they want to turn on. The user should be able to input either red or green, and based on their choice, your script should turn on the corresponding LED while turning off the other. Make sure your script can handle invalid input and provide feedback if the user enters something other than red or green. This assignment will allow you to practice using Python to interact with GPIO components while also adding user interaction. You'll find more details about the assignment in the Canvas course. This lab demonstrated the ease of controlling external components like LEDs with Python in the GPIO Zero library. In future labs, we'll build on these concepts, exploring more complex components and programming techniques. Feel free to experiment with the code and explore additional functionality within the GPIO Zero library.